Welcome everyone to another after work open source Linux hobby time YouTube live stream here on this channel. Personally growing a little bit frustrated with LVM 16 and Rust C somehow randomly regressing and not being able to link Firefox. Spent way too many boring hours with that over the last days. Recurring themes, only constant change, and regressions, and oversized, monolithic, supersized, too big to fail projects. Anyway, GCC 13 is out, and naturally, of course, I started to compile a whole like bootstrap from the ground up out of nothing. A whole Linux distribution because only a handful of people, so doing the unthankful job here of someone needs to test this stuff. Of course, on all 30 plus architectures we support here, from ARM to RISC-V, previous videos. So let's start the embarrassingly massive parallel build here. Epic thread gripping through that on a Ryzen 7950X. So what is new? The usual caveats, some stuff removed of offloading Intel NIC and other vintage abandonware, HPPA, HPUX, Solaris, and all the other unsupported Linux systems. But what is new is amazing stuff. OpenMP, lots of reverse offloading, now supported for AMD Graphics Next and VPTX. Lots of new OpenMP 5.1 features added, initial support for other features. Address sanitizer of not memory safe languages, but let's at least quirk some stuff left and right before everyone migrated to Rust. Detect stack use after return is now enabled for Linux targets if you have broken code and that randomly fails and stuff because someone else couldn't program in C. Recurring theme here, right? Felix from Leitner, libc, amp-utils, and all the other amazing code quality. You can disable this with as an option detect stack use after return equals 0, aka unsafe as in unsafe. New debug option for compressed debug info, link time optimization improvements, LTO support job server of the recently GNU make, named pipes, but that also had some regressions in the complexity. Also, I wonder if I influenced this because this, I recently was surprised by this. I mean, I kinda knew that, but I was probably last year majorly surprised when stuff randomly broke for me. I made a YouTube live stream here as per usual, and I patched this in the amazing industry, soon leading, enterprise ready, embedded and stuff, T2 Linux distributions. So what is default in T2? And I made a YouTube video about this because it was totally annoying and whatnot. And now, after years of being the standard, so share, like, subscribe, Patreon of us influencing the IT world being a better place for fast mass, unsafe mass optimizations will no longer add startup code to alter floating point environment when producing shared objects with shared. What took you so long? Only one YouTube live stream. You're welcome. GCC now emits its diagnostics with using serif, this JSON-based format suited for capturing results and stuff. Languages, thankfully, alphabetically ordered, so ADA comes first. Traceback support also, are we still in? Also GCC cross-compiler, at least bootstrapped. We are already in LVM. Let's see how the rest goes. ADA, traceback support, RT, MS, PowerPC, ELF, ARM architectures. So like ADA are the most important languages, right? ADA, which recurring theme. I understand it's alphabetically sorted, but maybe sort this by priority and stuff, because probably next to nobody. Anyway, it's using it. So C Langry, the unsafe Langry everyone loves here and adores and stuff. New warnings. XOR used as power once about using exclusive operator when it appears to be also used meant exponentiation. It's like do. How can you make a compiler slower and stuff for sort of like you probably should notice in testing if you ever test your code a single tiny bit. But anyway, New attributes documenting int arguments that are file descriptors, so the usual attribute magic for fdarc and read and write, as used with fanalyzer to detect misuse of file descriptors, trying to make C a safer place. New standard attributes, portable assumptions, support also for C and older, C++ for attribute assume expression or whatever. Several C23 features of that previous system programming language still being developed, introduced null pointer constant, enhanced enumerations, relaxed requirements, type inference, constant expression, probably with C++ compatibility or so, no return attribute, support for empty initializer braces, removal of tree graphs. Do you know what tree graphs are? Probably you want to Google that, and then it's like, why is this still supported? It was hard to type on some 70s or 60s teletype things, tree graphs. You had me at that. Additional C23 features, existing features adopted in C23 have been adjusted to follow the C23 requirements, not diagnosed with standard C2X W pedantic. Anyway, C++ excessive precision support which has been available in C since GCC 4.5. It's like after a decade, apparently it's now been implemented in C++ as well. The future is now. Amazing stuff. Enabled by default, and so on, yada yada. Option mainly affects IA32 using x87, and in some cases Motor 68K. It's like basically next to nothing. We have float and double expressions using long double precision, and S390 float expressions evaluated in double precision. Who cares? Several C++23 features have been implemented as well. Labels at the end of compound statements, type traits, deprecation of alternate compound operations, we're still building. Character 8T compatibility and portability fix, static operator removal, like white character, static operator. UTF-8 support for UTF-8 as portable source file encoding. 2023, the future is now. New warnings and no standard lib++ option has been added to enable linking with G++ without implementing linking in the C++ standard library. Whatever. Runtime library, improved experimental support for C++20, improved experimental support for C++23, and support for other experimental scope and synchronous values. Fortran finalization is now fully supported. Go GCC 13 provides a complete implementation of Go 1.18 user packages. Also Go 1.18 includes support for generic programming. That support is not yet available in GCC. I have to say, I recently wanted to build a new amazing open source, probably previous live stream. What is the name? Did we package that in shell? Oh my, where is this? Is it oh my, whatever, crazy names. Oh my posh, implemented in Go. And that did not build for me with GCCs. Also something failed. OVM failed. For what did fail here? That did not fail before. Segmentation fault. Internal compiler error. Segmentation fault. So what would be the right thing to do is on Salvage 2. It is a pre-release and test is going to test and stuff. Also, I mean, why, like, it's like, yeah, 2023, GCC, I mean, yes, it is a pre-release, but C, command pass, file of expand, defer, maybe clone body, push to top level, why trials, I mean, yeah, trial stuff of compiling LVM, but yeah, I guess that's the reason why it's not yet released. Excuse me. Yeah, I got some cold again. So yeah, that is that. We could, so the problem is that will prevent some stuff from building, which is obviously not ideal. So much to that beta testing. Also, lots of patches. So we had quite some patches, MIPS and whatnot, Spark, all those do not apply anymore, including my fast mess stuff there. And so yeah, obviously. So the question is how much, I mean, I appreciate alternative implementations, but if they can't build the one tiny modern shell thing that I would want, then how good is it? Welcome everyone. Yep, it's spring. And thankfully it's raining for the harvest this year, so we need something to eat, obviously. So yeah, it may or may not work. And in T2, I'm tempted to switch that over, because for simplicity, we did ship the GCC based core implementation, because it just built, but then it can't build Omer Posh, which obviously is a number one important and requirement for gracious living in the 21st century. And yeah, I might switch this over just to have a full feature audit, because what good, I mean, yes, alternative implementations are amazing as a somewhat not memory safety borrow checker Rust implementations that they are including. But at the end of the day, if it's not like fully usable, then it's like, sure, it compiles a hello world example, but not real code. So yeah. Modular 2, support for language. Modular 2 has been added, including support for ISO IEC 10514. So of course Clang, because I mean I could try another optimization, but so basically, yeah, it's not ready. I mean, I'm a little bit surprised that it failed that easy. You would think, sure, they have an enormous test suite, which obviously previous video test suite important, right? Because what's not tested is broken, as we just uncovered here. And I'm still surprised like that other people from Red Hat and SUSE, other maintainers that maintain GCC more than I, obviously not. I only mostly use it and send some occasional patch and bug fix. And then they still have not applied my, in the meantime, probably 2-year-old fix for fixing G5 and IBM Cell for not setting the wrong Power 7, I believe. It's like due. It's a freaking one-liner or so, and I submitted it like 2.5 times, and like still not. I probably. It's like, yeah, how much time should I spend on this stuff, right? You send it upstream, 2 years later, nobody cares, and you have pinged them already 2.5 times. It's like 2 times, and on Twitter. Anyway, AArch targets support decimal floating point, number of CPUs through dash mCPU and mtune options have been added. Support has been added for other ARM9 and so on. AMD Radeon. I'm a little bit surprised that they support Lyre, if that is really that valuable in GCC, but I guess alternative implementations choice is always good when stuff breaks and so on. As AMD vectorization has been improved for AMD Radeon GC, and I wonder if someone really ever uses it, but whatever. Number of CPUs supported have been added. Support has been for M profile, pack, whatever. Lots of new ISA extensions, because the only thing more complex than x86 is next year's Intel's crazy x80, 86 extensions. For what did they add this time? BF16 type for SSE2 has been enabled. BF16 type for AVX 512 BF16. New ISA extension, AVX, IFMA, VNNI, and 8, any convert, and so on. AMX FP16 prefetch. Now supports new Intel Raptor Lake, Meteor Lake, and Sierra Forest through equivalent MArch options. NVPTX default value of MArch option has been changed. Whatever. So RISC-V, that is super silly. I'm really not a fan, if not to say I kind of hate that this vendor I believe it's probably T-head, but I could be wrong, added this X thread. So what this is, I have not researched how binary compatible that is to other RISC-V extensions, but it's not like what I really dislike, if not hate, we're also building Python, is that, what's the drop frames? I hope we don't have drop frames with my load being 100%. That they didn't implement the RISC-V work in progress extensions. I didn't investigate, maybe I should, but I don't really care, because I really hate vendor extensions. I don't want RISC-V to become a mess. Of course, they are legally, as per the RISC-V implementers agreement thing, probably being allowed to do that. But the problem is you generate binaries that only work on those vendors' RISC-V processes, and that, in my opinion, totally sucks, especially with lots of this similar extensions of bit manipulation and vector extensions and stuff are being worked on, if not final, in the meantime. So yeah, this is extremely silly and probably something I usually don't wish stuff to be deprecated. I really enjoy using my UltraSpark and HPP ARISC and other Super H and whatnot stuff here, just for the fun of it and so on. And I really hate to support vintage and retro stuff for decades to come, but I really don't like adding this completely pointless, short-lived, YOLO, you only live once, collaborate together, incompatible vendor stuff in this day and age. So it's kind of seldom that I wish this to be. Sorry, I should have a big mute button here. But yeah, you gotta work what you gotta work. So yeah, I hope that's being removed eventually. So if in 1 year, 5 years, or 10 years we upload like, hey, this incompatible extension that nobody cared about is being removed again. Yeah, operating systems and improved static analyzer. So analyzers gain 20 new warnings. You can never have enough warnings scrolling by there, obviously. The only substitute for threads and IPC is more threads and IPC, and performance is performance because analyzers. Improve for plugin authors. Diagnostics can now associated with rules such as from code standard documentation specifications. Rules have a code name and can have a URL which GCC can print and text from capture in this serif like that. So this might not be all. It is work in progress, and it already infamously internal compiler error till live on me. Anyway, if it is being so, I pre-tested that. I had hoped it would work more amazing than instantly icing on LVM, because as I said, I currently have some major headache and regression with LLVM 16 and Rust, which is super effing annoying and burned way too many hours of my precious time. I hope that, like, hey, maybe we switch to GCC and this magically goes away, but yeah, GCC developers, hold my beer. We need to compiler error. We need to internal compiler error first. Yeah, so we could kind of stop this experiment here already, but it is good to know that it still bootstraps with all our cross-compiling bootstrap out of nothing, bootstrap from zero. Like configures, we have so much configure magic and flex and quirks and features. At least for AMD 64, it builds except ISIS on LVM so far. Some patches need rework, like the mentioned, maybe inspired by my videos, fast stuff here, and but also MIPS and Spark, all our small little quirks and features, so that stuff just freaking works TM for us. And I probably have to further guru meditate all about this super annoying, hard to debug and analyze Rust and LVM16 regression. That's it for this video as usual. I hope you enjoyed this dedication and learned something. Don't forget to share, like, and subscribe there. Have a good day and night, and I hope to see you soon for the next fun stuff testing and low-level code fun to come.